Assalamu alaikum dear students. Welcome you all to AppSec's online sport program 2020 Mathematics Class 8th. This is the title of your book, Mathematics 9 Science Group. We will cover pages 9 till 14. As we have started Unit 1, Matrices and Determinants, we will cover the topic Types of Matrices. Your resources are textbook, internet, cell phone and tablet. And here's the summary of the lesson: Types of Matrices and Addition and Subtraction of Matrices. This is the quote of the day. Now, today's objectives. At the end of the lesson, you people will be able to know about more types of matrices and the method to add and subtract two matrices. But first of all, recap. As we have started Unit 1 and you learned about a matrix and its types. First of all, what is a matrix? A rectangular array or arrangement of a collection of real numbers and then enclosed by brackets is said to form a matrix. The horizontal entries are known as rows and the vertical entries are known as columns of a matrix. And what is the order of a matrix? The number of rows and columns in a matrix specifies its order. It means if a matrix have 2 rows and 2 columns, its order would be 2 by 2. Equal matrices. What are equal matrices? If two matrices A and B are said to be equal matrices if the order of A is equals to order of B, and the second condition is their corresponding entries are equal. Then you have learned about types of matrices. A matrix consists of one row is said to be a row matrix, and a matrix consists of one column is said to be a column matrix. If the all entries of a matrix are 0, then this matrix is said to be a null matrix or zero matrix. Diagonal matrix. If the diagonal have values, have entries, then this matrix would be a diagonal matrix. If the diagonal values are same, then this diagonal matrix would be a scalar matrix. If the diagonal entries are 1, then the diagonal matrix would be a unit matrix. Now, what is a square matrix? If the number of rows and number of columns are equal in a matrix, then matrix would be a square matrix. As in this matrix, order is 3 by 3. It means it is a square matrix. But on the other hand, the order, the number of rows and the number of columns in this matrix are not equal. It means this would be a rectangular matrix. Now our first topic is transpose of a matrix. Transpose of a matrix is obtained by changing rows into columns and columns into rows. It means the transformation of a matrix by changing its rows into columns and columns into rows is a transpose of a matrix. For example, here we have a matrix and we want to convert it into its transpose. Here is a row. When we convert this row into column, it would be 6, 4, 24 in the row form of columns. Similarly, this is the conversion of this row into a column. Next example, we have a matrix and its transpose would be like this, because here we have converted its row 1 to 4 as a column of this matrix 1, 2, 4. Now time to think. Now you have to find transpose of a matrix. Matrix A is given. Find out its transpose. Similarly, we have another example. And now it's your turn to think about, follow this pattern and find the transpose of these two matrices. Now you task 1, question number 5 and 6, exercise number 1.2. Now addition and subtraction of matrices. Two matrices may be added or subtracted only if they have the same order, that is, they must have the same number of rows and columns. And what is the second step? Addition or subtraction is accomplished by adding or subtracting corresponding elements. It means first we have to check whether the order of two matrices are equal. If means they can be added. And secondly, how can we do the addition? By adding their corresponding elements. So first of all, we will check with these examples. We have two matrices. Check their order. If their orders are equal, then we can add them. Otherwise, they are not conformable for addition. The order of first matrix is 2 by 2, but the order of the second matrix is 3 by 2 because it has 3 rows and 2 columns. It means these two matrices are not conformable for addition. Similarly, you can check these two examples. Check their orders. If orders are same, they can be added. If orders are not same, not be added.
Now, example. We have two matrices A and B. How can we find A plus B? Corresponding elements mean this is the first element of this matrix. It should be added with the first element of second matrix. Now 5 would be added with -1. You can see in the next step 1 plus 12, 5 plus -1, 7 plus 0, 3 plus 9. Why 3 plus 9? Because the corresponding element of 3 is 9. Now 1 plus 12, 13, 5 minus 4, 1, 4 and 7 plus 0, 7, 3 plus 9, 12. So after adding these two matrices, we will get this matrix and this is the resultant of A plus B.
Now subtraction of matrices. We have two matrices A and B. Same procedure. Corresponding elements would be subtracted as shown with the arrows. 0 minus 2, 4 minus 8 and 3 minus 5 because they are corresponding elements of each other. So after doing subtraction, you will get -2, 7, -4, 1, -2 and 9. So both addition and subtraction have same method to add and subtract. First condition is their order must be same, and second condition is corresponding elements would be added or subtracted to add or subtract two matrices. Now thinking time. Can you add two matrices that are different sizes? Check the order of these two matrices and find their answer. Next example, two matrices, subtract them and find its resultant. In the third example, again we have two matrices, solve them according to their operation and complete it. this is your task 2, exercise 1.3, question number 1 and question number 6. You can use this hint to solve question number 6. Now, multiplication of a matrix by a real number. Let A be a matrix and the number K be a scalar, K be any number. Then scalar multiplication of a matrix A with K is obtained by multiplying each entry of matrix A with K. It is denoted by KA. Now example number 1. Here we have 4 and 4 is any scalar number, any number, and we have to multiply this 4 with this matrix. You can see as mentioned with arrows that this 4 would be multiplied with each and every entry of the given matrix. So 4 multiplied by 10, 4 multiplied by minus 9, 4 multiplied by minus 1, or 4 multiplied by 4, and it would be this matrix. So this is the resultant when we have to multiply a scalar quantity, a scalar number with any matrix. And your key point is, if you want to find a multiple of a scalar with the matrix, you have to multiply each and every entry with this number. Now your turn. Multiply a matrix by a scalar. Now scalar is minus 3 and you have to multiply minus 3 with this matrix. So think about it and write your answer. Now your task 3, exercise number 1.3, question number 3. Now recap. Transpose of a matrix. Transpose of a matrix is obtained by changing rows into columns and columns into rows. It means it is a transformation of a matrix by converting rows into columns and columns into rows. And next was, how can we add and subtract two matrices? Two matrices can be added or subtracted if they have same order. And how can we do the addition? By adding or subtracting their corresponding elements. Multiplication of a matrix by a real number can be obtained by multiplying a number with each and every entry of the given matrix. This is your assignment, task 1, task 2 and task 3. So by following all concepts and all methods, complete your assignment and submit it as soon as possible. Thank you so much.